welcome to another problem session. So, we are doing things that show up in MCAT or JEE prep. So it's going to take a long time to cover all the courses, everything. But here is a set of problems we've done. Inclined plane problem. Two masks on top of each other and one of them being pushed. One pulley, like that. We haven't done the two pulley problem yet, or three pulley problem, but we'll do them. And then there's, suppose you have a table, frictionless table, and you have a big book and a small book. We don't know which one is bigger mass. Okay, just it's M1, M2, so easy to draw. And I'm pushing on the first one, and the question is, what's the force between them? And also, what's the acceleration of one? What's the acceleration of two? Okay, so we're going to do this one today. We're going to do very quickly. Another one is a vertical track. And maybe this is a toy car going around. Going around. I should do going around. And and we want to play with this kind of toys. You know that if the speed is not good enough, it's not going to make it. It's going to just fall off. It might just fall off here. It might fall off here, but if the speed just right, it will just make it. So we want to know what the speed should be, so it just makes it. And over here there may be another speed, and we want to know how much force that if the car is here, how much force the car will apply on it. You can do over here how much force the car will apply, how much force the car will apply, things like that. And finally, I want to do a horizontal circle. So this is like a cone. So this cone and cone angle theta, and something is going in circle. Doesn't look circle, but if you look from the top, it's going to be circle, and this circle has a radius r, and of course, if depends on where if you're over there, the r will be bigger. So this is a particular r, and is going with the speed v, and it doesn't go up or down. It maintains it. So what's the condition if it's a frictionless and it's going like that? What should, how is that possible? Okay, so what the condition should be there so it's possible. Okay, let's do this one. So what's the acceleration? First, two of them have, if they're moving, so because this is a frictionless, there's no friction, static or kinetic, to oppose it. So any amount of force will make it accelerate, right? So F greater than 0, accelerate. So we don't have to always frame it as a two problem. The two of them will have same acceleration. Constraint, they move together. Move together. Amount of distance, this moves, same distance, this moves. This means A1 equals to A2. So this is common A. Don't have to do A1, A2. Now, if you think of this whole thing as one system, so we have thing looks like this. Excuse me. And horizontal force is F, and let's call it M equals M1 plus M2. So this will be capital Mg, and from the table we'll have a normal force on the whole thing. So this system, you can choose x-axis this way, y-axis this way. So in the y-axis is balanced, and acceleration is all along the x-axis. So acceleration is going to point that way, and magnitude A. So you can say acceleration vector is A0. F vector is F0. Fn vector is 0 Fn. So this is the x component, and this is the y component. So here is just the y component. Weight, this is the weight, is 0 minus mg. This is the y component, weight x, and this is Fn vector x. Fn is the magnitude. And so along the x direction, it just gives you F equals capital Ma. That just A equals to F over M. These other ones we don't even know. So we got the acceleration down. So that was the acceleration one, and so we answered the question. The other question was to find the force between them. But now I have to look at separately. So it doesn't matter which one you look at. Let's look at M2. So if you look M2, so the problem is this is not acting on M2. This is common mistake from the students, I find. So the only force that coming from horizontal M2 is by M1. F by 1. Let's denote this F1. And of course, if okay, so this is and then you have a M2G, and then this Fn2. So this normal on this guy. As a result, this is going to acceleration, and it's the same acceleration. Okay, so it looked like it's not recording. So all right, let's carry on. So from here, this F1, if again do x and y, and along x, it just F1 force by 1 on 2 equals to mass of 2 times A, and A is F over M. So M2 F over capital M, which is M2 over M1 plus M2F. So we got this by looked at number 2. How about if you look at number 1? So we're trying to look at the force between them. It should be same if I just use this guy. So let's use that guy. On M1 you have a outside force F, and then you have this force, this F1, which pointed backward. And of course you have M1G and Fn. As a result of all that, this object is going at acceleration A, same acceleration as that guy. So now this will be F minus F1, F minus F1, M1A. So M1A is going to be M1 F over M1 plus M2. So we want F1, check if this is the same as that value. F1 is F minus M1 F over m1 plus m2. Sure enough, if you do m1 plus m2, m1f plus m2f minus m1f, and cancels out, and it's the same as m2f over m1 plus m2. And if you want to be more dramatic, you could say, oh, let's see, force by 2, and let's call this F2. And so this will be F2, this F2. Of course, that should be equal to F1 by third law, right? And they're consistent with each other. All right, so that's that problem done. Let's do the vertical circle. So we already know the vertical circle, so I'm going to draw it over here. Vertical circle. It's a very commonly asked question. So here is a P, the Q. I think I draw R on the right side. I don't know why it's R and S like that. This is a little bit stupid. Let's call it A and B. Okay, because we can use the letter R for radius R. First question is, what's the minimum speed? This should be there. So if you increase the speed, let's first look at what if it's going in a circle, one thing we know is the acceleration will be pointed towards the center. So the acceleration, so at P, so this is at P, we should write down acceleration is pointed down. Acceleration is pointed down, and its value, acceleration is pointed down, and its value is v square over r. V at P r squared. So let's call it v at P here, because they may have different values at different places. What other forces are there? So if you look at P, so the situation about acceleration, the situation about forces is, switch the ink now, forces will be mg pointed down, and if you look at here is a track, here is the object, so the normal force will be pointed down, not up. Let me draw it a little bit bigger. So here's a track, and it's moving like that. So that's the surface. So this thing is pushing down on it. The track is pushing down when it's over there. So the normal is pointed down like this also. The normal will be different at different places, okay? So we're just talking about P. So in the P, this is the situation, acceleration is that. So if you take, say, y-axis this way, they're all in the same axis. This plus this equal to m times a. So you have a Fn plus mg, and this is true for any speed at P. So this for any Vp. We want minimum this, so if this was 0, that will be the minimum. When Fn is 0, right? So because these are adding, so this get bigger. You want to have a smallest value this side to get a smallest value that side. The smallest requires a smallest, and this smallest requires Fn equal to 0. So in that case, mg is m over r Vp min square. M cancels out. So Vp min is, and it's a speed, so I'm going to have to square root, just give a positive root speed. Okay, so that's the point P. Let's look at a point Q, and maybe Q and maybe A. So what will happen at Q? At Q, it will have some speed v at Q, but if you look at this now, is above the track. So the normal now is above the track, Fn at Q, and gravity is down mg. So you can see now it's opposite, and speed is this way, but the acceleration is that way. So acceleration is mvq square, vq square over r. So if you write down, maybe this is the positive axis, so the Fn minus mg was mvq square over r. So at this, you're going to see that equation. Let's look at A. What will happen at A? All right, so this is A. Acceleration is pointed that way. Acceleration, and so this is A. And so the acceleration here is v at A is square over r. But pretty interesting. You have Fg, well, mg, and so weight is pointed down, acceleration point that way. The normal will have to point in some direction. Normal has to point in some direction so that this plus this vector plus this vector will be mass times acceleration vector. So you have a Fg vector plus Fn vector is mass times acceleration vector. So these two have to add up to this, and that's how we're going to get Fn from. So Fn will have a now look at this, a little bit complicated, right? So x and y, you break it, and we don't know which way the Fn is pointed. We know which way this pointed, which way this pointed. From there we can figure out. So let's look at x. In the x direction, we're going to have some Fnx, mg will be 0. On the other side, it would be minus m va square over r. So this gives me the x component of this force. In the y direction, we're going to have Fny minus mg, but the acceleration is 0. So this gives me y direction force. So Fnx is minus mva square over r, and Fny equals to mg. So we can draw it out, and if we had a numerical value, it would be nice. So this x-axis, this is the y-axis, it's a negative value over here, minus mva square over r, and maybe this is mg value is that much. So this is fnx, and this is fny, which is mg. This is the fn. The magnitude of this will be, it'll be square root of fn x square plus fn y square, as you know from the vectors. And you can get this angle theta. Theta will be arctangent this divided by positive part of this, because we're just looking at positive part. mva square over r mg. So this is going to be arctangent gr over va square. All right, so this is, try doing what will happen over here. Okay, now let's move to our last example today. Okay, so it's a horizontal circle. So is going in a circle like that, and radius is r. Sometimes it is given theta here and this distance here. From there you can figure out the r. Okay, so if this was a b, then if this is theta, then you can see I need this guy, this b, so r will be b cosine theta. So theta 90 degrees will be 0. That looks correct. Okay, all right, so yeah, this will be okay. This r, and so this is like this is the plane. If I were here, say I'm going that way, mg is pointed down below, right, perpendicular to the plane. Acceleration is pointed in the plane towards the center. Acceleration pointed that way, and magnitude is v square over r. Acceleration. Okay. Clearly, if this can't be all the forces, if you look at x, if you draw axis here, x, y, z, so you got all of this going now. Then to whatever the track, whatever the funnel, so let f be the vector force by funnel surface on block. So we don't know it's going to be, this will have fx, fy, fz, and we need to figure out all of them out. Okay, so this is the normal force. So let's see, we have no friction, so that's the normal force. All right, let's see what we come up with. So acceleration is, vector is going to be minus v square over r, 0, 0. Weight is 0, 0 minus x, y, z is that way, mg f is just fx, fy, fz. So from here we already know fx equals minus mv square over r, fy is 0, and fg is mg. So the funnel, the force from the funnel will be in the xz plane, and it's almost like what we did over there, right? So if I look at this x and this is z, over here minus mv squared over r, and this is mg, so it's exactly what we did over there. So the normal force here is square root of fx square plus 0 plus fz square, and this theta again will be arctangent. It's going to be same problem here, we gr over v square. So these problems kind of similar, because this is, although this is not a vertical circle, but the problem, the way the setup works out is the acceleration is this way, where the gravity is pointed that way. So the normal has to point somewhere so that these guys add up to be in that direction. All right, so I think that's completes today's exercise. Next, what we want to do is a little bit more complicated multiple pulley problems. So I'll see you then. Meanwhile, I want to just remind you to subscribe to this channel if you can. If you haven't already, you can get notification. You can also check out my website, where I've solved many more problems than this. All right, take care, bye.